Welcome back to the science class. Today we are going to learn about a new chapter. Students, open the textbook at page number 148, chapter number 13, States of Matter. Shall we start the topic? Yes. Now let us learn about mind map for this chapter. So, the chapter is about states of matter. So, what do you mean by matter? Matter is nothing but the things that occupy space and have mass. Okay, anything, say the scale or a chalk or dust or anything, it will occupy some space. Is it not? It will occupy some space and it has its own mass. So, things that occupy space and have mass is said to be as matter. Okay, so this matter is made up of molecules. What is that? Molecules. So what do you mean by molecules? Matter is made up of tiny particles called molecules. Tiny particles called molecules. Okay, now then next thing is about properties of matter. We are going to learn about different properties, that is volume, size, shape, mass, color, density and so on. Clear? So generally matter is classified into three types. What are they? That is solids, liquids and gases. Solid, liquids and gases. So what do you mean by solid? Molecules in solids are packed tightly and held together by strong force of attraction. See, what is this? The molecular arrangement in solids are packed tightly. They are packed tightly. Clear? And then the attraction, the force of attraction between the molecules is strong. Clear? Next thing is about liquids. What is that? Liquids. So what do you mean by liquids? Molecules in liquids are less tightly packed and they have space between them. They are less tightly packed and they are having space between them. Clear? The force of attraction between the molecules are not very strong. They are not very strong. Okay. Next thing is about gases. The third type of classification is gases. So what do you know about gases? Molecules in gases are loosely packed with lots of empty space between them. So the molecular arrangement is they are loosely packed. Okay, then the force of attraction between molecules are very weak. They are very weak. So we are going to learn about this in this chapter. Children, there are so many objects surrounding us. Say for an example, scale, chalk, duster, so many, is it not? So each and every object occupy certain size, shape, mass and all. Is it not? Yes. All objects have certain size, shape, mass and occupies space. If I am saying for the example, the scale, it will occupy some space. Is it not? Yes. It can be large or small. Object can be large or small. It can occupy either lot of space or very little space. Okay. So now, what do you mean by this matter then? All living things, either living thing or non-living thing. All living things that occupy space and have mass is said to be as matter. Not only living things, all living and non-living thing including human is said to be as matter. So anything that occupies space and mass is said to be as matter. Clear, children? Yes. Now, what does matter contain? What does this matter contain? So, all matter is made up of tiny particles called molecules. What is that? Molecules. Okay. A molecule is the smallest unit of substance. It is the smallest unit of substance which cannot be seen through our naked eyes. Means we can see these molecules only through microscope. Clear, children? Yes. Matter is made up of atoms. Again, molecule is further made up of atom. Okay, I said matter is made up of molecules and molecules is made up of atoms. Different objects are made up of different atom. Okay, it's not a common thing. Different objects are made up of different atoms. For example, silver is made up of silver atoms. Silver is made up of silver atoms. While salt is made up of two different atoms. What are they? Sodium and chlorine. Clear, children? Yes. Now we have learned about what do you mean by matter and what does it contain. Mean to say molecules and atoms. Clear, children? Yes. Yes, children. Now let us learn about properties of matter. What do you mean by properties? See, if I am taking the scale as an example, this scale has a certain shape, certain color, size, it occupies some space, mass, it has some mass, weight, is it not? So these are all properties. Okay. So volume, size, shape, mass, color, density are properties of matter. So these are all different properties of matter. Clear, children? Yes. So generally matter exists in three different states. What are the three different states? Solid, liquid and gas. Is it not? Yes. So all the three states have different arrangement of particles. What is the main difference between these three states? Yes, children, that is their molecular arrangement. Their molecular arrangement. Okay. So there is a difference in between the molecular arrangement of these three different states. Clear? Then matter can change its form from one state to another. So if it is a solid, it's not conditioned that always it should remain as a solid. It can change, matter can change from one state to another. Say for an example, a solid can be transferred to liquid and then liquid can be changed to gas. Okay. So what they are coming to tell, what they are telling here, matter can change its form from one state to another. Clear, children? Yes. Yes, children. Now let us learn about solids. Okay. So you can see arrangement of molecules in solid. So how it is? The molecular arrangement is tightly held together. Is it not? Yes. Molecules in solids are packed tightly and held together by strong forces of attraction. So they are held together tightly and they have strong force of attraction. Clear, children? Yes. They have no space between them to move around. They have no space in between them to move around. So they are very tightly packed. Okay. That's why solids have definite shape and volume. They have definite shape and volume. We can change the shape and size of solids through physical process. Say for an example, a pencil can be broken down into two pieces. Is it not? Yes. So that's what about solids. Clear, children? Yes, children. Now let us learn about the second classification, that is liquids. Okay. So you can see the picture. So here they have described about arrangement of molecules in liquids. Okay, you can see the arrangement of molecules. We cannot say it as very tightly held together or it's not very loosely packed also. Is it not? Yes. Now about liquids. Molecule in liquid are less tightly packed. They are less tightly packed and they have space between them. They are having some space between them. Is it not? Yes. Also, the forces of attraction between the molecules are not very strong. How it is? They are not very strong. Therefore, it is possible for molecule in a liquid to move around in different directions. So, they can move in different directions. There is a possibility. Okay. Then, this allows liquid to flow and change their shape. So, how it will happen? This allows liquids to flow and change their shape. Since it is loosely packed, it can move here and there in different directions. So, that's why it will allow liquid to flow and change their shape. Clear, children? Yes. For example, if you spill milk on the table, it flows in different directions. Is it not? It flows in different direction and changes its shape. It won't exist as the same shape where you might have in a bowl or it might have in a tumbler or anything. So, it won't exist in the same state. It again spills somewhere, it moves in different directions. Okay, that's what about liquid. Yes, children. Now, let us learn about the third classification, that is gases. Okay, so you can see the picture for gases. Here, they have described about arrangement of molecules in gases. Okay, so how it is? They are loosely packed. Is it not? Yes. Molecules in gases are loosely packed with lots of empty space between them. So, in between the molecules, lots of empty space is there. Is it not? Yes. The forces of attraction between molecules are very weak. How it is? They are very weak. Thus, they can move away from each other very easily. So, they can move from place to place very easily, they can move. Okay. Therefore, gases neither have fixed the shape nor a fixed volume. Is it not? They are not having a fixed shape and it won't occupies always a fixed volume and all. So, most gases are colorless and we cannot see them. Is it not? We cannot see the gases with our naked eyes. That is, they are colorless. That's why we cannot see. Most of the gases are colorless. Clear, children? Yes. Yes, children. Now, let us learn about changes in the state of matter. So, as I said, there are three different states: solid, liquid and gases. Now, these three different states can be changed from one state to another. Okay. So, that's what we are going to learn now. Let us, matter changes its form from one state to another on heating or cooling. Okay. Either by heating or cooling, a solid can be changed to another state. A liquid can be changed to another state. Clear? Then, when a solid state of a substance changes into liquid state, then it's termed as melting. It is said to be as melting. Okay. On heating, water changes into water vapor. On heating, water changes into water vapor, which is gaseous form. Is it not? It is changed to a gaseous form. When a liquid state of a substance changes into a gaseous state, then that is said to be as vaporization. Children, I repeat, when a liquid state of a substance is changed to a gaseous state, then that is said to be as vaporization. Clear? Therefore, on heating, a solid changes into liquid. Is it not? While heating, a solid changes into liquid, and then a liquid is changed into gas during heating. When you are heating, a liquid also will turn into gas. Clear, children? Yes. When a gaseous state of a substance changes into liquid state, when a gaseous state is changed to a liquid state, then that is said to be as condensation. What is that? Condensation. For example, water vapor on cooling changes into water. Is it not? Water vapor, when it gets cool, again it will turn back into water. Is it not? Yes. Now, pour some water in an ice tray. Where? In an ice tray, and keep it in freezer. You all know what will happen? After few hours, water has changed into ice. Water will become into ice. Is it not? Yes. When a liquid state changes into a solid state, what is that? It is said to be as freezing. Is it not? When liquid state changes into an ice, water is changed to ice. Is it not? Then that transformation is said to be as freezing. It is called as freezing. Okay. Thus, on cooling, a gas can be changed into liquid. On cooling, a gas can be changed into liquid, and a liquid can be changed into solid. Clear, children? Yes. Then, the temperature at which a liquid becomes a solid is said to be as freezing point. The temperature at which a liquid becomes solid is said to be as freezing point. Okay. And the point at which a solid changes into a liquid, the point at which a solid changes into a liquid is said to be as melting point. Is said to be as melting point. Water is the only liquid that expands on freezing. What it will happen? What it will take place? Water is the only liquid that expands on freezing. Clear? Therefore, in colder regions, water pipes usually burst due to expansion of water. Clear, children? Yes. Yes, children. Now you can see 3 different glasses with water. Is it not? Yes. So, there are 3 glasses. You have labeled it as A, B and C. Can you see this? Yes. Now, we are going to do an activity to learn about solubility. Solubility. Okay. So, to the first glass, that is A, I am going to add some amount of sugar. Can you see this? Yes. I have added sugar. Okay. Then, to the second glass, I am going to add some amount of salt. Can you see this? Yes. Added salt. And to the third glass, C, I am going to add some sand. Can you see this? Okay. Yes. Now, what I am going to do, I am going to mix all the three things what we have added. Yes. Now it is, we have mixed, so it is dissolved, is it not? Yes. Now next thing about salt mixed with water. Now I have mixed this. You can see that it is completely dissolved, is it not? Yes. Now about the third glass, glass C, I have added soil and water, is it not? So I have mixed this. So how it is? It do not dissolve, or else it is insoluble in water, is it not? The sand particle do not disappear. It do not disappear. You can see the layer also, is it not? You can see this layer, because it do not dissolve in water. The particles settle down at the bottom of the container. Whereas in sugar and salt, they dissolve in water. They are soluble in water. And sand is, they do not dissolve in water and they are insoluble in water. Clear, children? Yes. Now let us learn about the next part of the chapter, that is, most gases are soluble in water. Okay. So how it is soluble, that we are going to learn. Oxygen, carbon dioxide and chlorine easily dissolve in water. What and all? Oxygen, carbon dioxide and chlorine easily dissolve in water. Carbon dioxide is used to dissolve in soft drinks to provide it fizz. To provide it fizz. You could have noticed this, is it not? Yes. Carbon dioxide dissolved in water is also used by aquatic plants. Plants will use carbon dioxide, is it not? So that is used by aquatic plants to make food. Clear, children? Yes. Aquatic animals breathe in the oxygen dissolved in water. So the animals which are living in water will intake the oxygen which will dissolve in water. Clear? Then hydrogen is insoluble in water. Hydrogen is insoluble. It is not soluble in water. Liquids that mix with each other. Liquids that mix with each other is said to be as miscible liquids. What is that? Miscible liquids. For example, glycerin, alcohol and milk. What it will do? It will dissolve in water. It will mix with water. That's why that is also said to be as miscible liquids. Clear, children? Yes. Liquids that do not mix with each other is said to be as immiscible liquids. What is that? Immiscible liquids. For example, oil mixed with water. Oil mixed with water. So what happened? They do not mix. They do not mix and oil floats on top of water. It will form a separate layer on top. Is it not? Top layer and bottom layer will be there, where oil will float up and below to that you can see water. So they do not mix with each other. That's why that is said to be as immiscible liquid. Clear, children? So we have learned till now miscible and immiscible liquids. Yes, children. Now let us learn about physical and chemical changes. Okay. So, what do you mean by physical change? A change in which only the physical property of a substance such as size and shape is getting changed, then that change is said to be as physical change. Can you understand? For example, a paper which is torn into pieces, it still remain as a paper, but the size and shape alone will get changed. Is that not? It has the same property of paper, but still the size of the paper might get reduced. Is it not? Yes. It does not lead to the formation of a new substance. It's not turning into a new substance. It is same thing. It is as like the same paper. It has the same property of the paper. The size alone or the shape alone will get changed. Is that not? So, this sort of change is termed as physical change. Clear? Next thing is about chemical change. What do you mean by chemical change? A change in which a new substance is formed. When you are getting a new substance, then that change is said to be as chemical change. For example, if we burn the paper, it will change into ash. Is it not? It will change into ash. The property of the new substance, that is ash, is different from the original substance. What is the original substance? Paper. Ash is different from paper. Is it not? So, most of the chemical changes are permanent and cannot be reversed. Can we change the ash back again to paper? No. Is it not? So, that cannot be reversed and the change is permanent. So, usually the chemical changes will be permanent and which cannot be reversed. Clear, children? So, this is what about physical and chemical changes. Yes, children. Now, an activity for you all. What is that activity? Take some amount of water, oil and keep it in freezer. Some amount of water and some amount of oil and keep it in freezer. Okay. Check after an hour. Okay. So, what will happen? Did it will freeze? Did it freeze? Different material have different freezing and boiling points. Okay. You just do it and submit the report in your class email ID. Okay. That's what. So, children, with this we have come to an end of this chapter. So, after watching the video, read this chapter thoroughly so that you can understand well, and let me meet in the next class. Thank you all.